So we're given a rational inequality that's just made up of two monomials, and we're asked to solve and write the solution in interval notation. So our first step is to write the inequality as one quotient on the left and 0 on the right. And that's if we have separate rational expressions on the left. In this case, that step's already done for us. We just have two monomials, one in the numerator, one in the denominator, and therefore it is in this form. So our second step is to determine the critical points, the points where the rational expression will be 0 or undefined. So this rational expression, if we have x minus 2 over x plus 4, we know that it's going to equal 0 when x minus 2 equals 0. Whenever the numerator equals 0, that's when it's going to equal 0. So we're finding the places where it equals 0 first. So x minus 2 equals 0, so x equals 2. And where it's undefined is where the denominator is equal to 0. So x plus 4 equals 0. So x equals negative 4. So we use those critical points to divide the number line into intervals. So we have 2 and negative 4. So we'll draw a little number line here. We'll call this 0, negative 1, negative 2, negative 3, negative 4. So we have a critical point here and at 1, 2. So here are our critical points. We're visualizing them on the number line. And so we've divided this number line based on our inequality and our critical points up into three intervals. We have negative infinity, negative 4. We have negative 4, 2. And then we have 2, infinity. So here are our three intervals. So we want to test a value in each interval to determine, is it greater than 0? Is it equal to 0? Is it less than 0? So we can choose any point we want. We will start with, in our first interval, let's pick the point x equals negative 5. And then in negative 4, 2, we'll just pick the value x equals 0. And in 2 infinity, we'll pick x equals 4. So then we'll test those points in our rational expression. And we can break this up into, let's test them separately. Is it positive? Is it negative? With me, I'd like to do it a little differently. I just want to substitute into my rational expression and determine, is it positive, is it negative, or is it 0? Because that's ultimately what we're wanting to answer with any inequality. Is it positive, is it negative, is it 0? To determine which intervals satisfy the rational equation that we're given. So let's first test x equals negative 5. So at x equals negative 5, we have negative 5 minus 2 over negative 5 plus 4. Negative 5 minus 2 is negative 7 over negative 5 plus 4 is negative 1. So that ends up equaling 7, which is positive. So that interval checks. So we'll put a check mark down here to verify, yes, that is greater than or equal to 0. 7 is greater than or equal to 0, so anything on this interval is going to be greater than or equal to 0. Now, x equals 0. That's in our interval negative 4 to 2. So x equals 0. We have 0 minus 2 over 0 plus 4, which equals negative 2 over 4, which equals negative 1/2. So that does not check. That is not greater than or equal to 0, so I'm going to put a big X down here. And then last but not least, we'll check x equals 4 in our interval to infinity, 2 to infinity. So x equals 4. That gives us 4 minus 2 over 4 plus 4, which equals 2 over 8, which equals 1/4. 1/4 is greater than 0, so it's greater than or equal to 0. It satisfies that, so I'll put a check mark here as in that interval checks. So we can put here, this is positive, this is negative, and this is positive. Now what we need to look at is we need to determine, because this inequality is inclusive, it includes the equal, we need to include the 0 as well. And our 0 is at x equals 2. So in other words, on this interval where it's positive, where it satisfies our inequality, this interval is going to end up with a square bracket because of the fact that 2 is a 0, and 0 is greater than or equal to 0. So our solution in interval notation is going to be negative infinity to negative 4, combined with, which we represent with a big U for union, square bracket, because at 2, if we have 2 minus 2, that's 0, which is greater than or equal to 0, because it's equal to 0. So we have a square bracket 2 to infinity. In these two intervals, the inequality we're given is going to be true. It's going to be greater than or equal to 0.